In our Unit 3 puzzler, you saw the setup for a demo with two billiard balls racing down two different tracks, a red incline with a valley or dip, and a yellow straight incline. You were asked which ball will make it to the bottom first, the one on the yellow, the red, or they'll reach there at the same time, and which ball will have the greatest final velocity, the yellow incline, red incline, or both the same. Let's watch the video to the end to see what happens.
So, as you can see, the ball on the red track finished first. This is because when it hit this downhill area, it had a greater speed. When it reached this region, it was still accelerating at the same rate as the ball on the yellow track, but it had a greater velocity along this segment. When it came back up the hill, it slowed down to a velocity equal to the velocity of the ball on the yellow track once the ball on the yellow track reached this point. But by the time the ball on the yellow track reached this point, the ball on the red track was already way ahead and finished first.
So why does the ball on the red incline win? The balls start out with equal slope or acceleration, but then the red ball has a big increase in acceleration. And I've shown here the component of Fg, the force of gravity, acting along the slope. So part of it will be acting normal to the surface, and part of it will be acting along the incline or the slope. And so you can see that there's a much greater component of gravity acting along that valley or that first dip. The slopes then equal again, and so you have equal acceleration. And then the red ball loses some velocity because we have a negative acceleration. But at this point, it has spent most of its time traveling at higher velocities because it had that early kickstart with a greater acceleration over here. And so it has a big lead on the yellow ball. But this is just a demonstration of kinematics, so we might have expected that. My second question deals with energy. Which ball will have the greatest final velocity? Perhaps if you guessed red for the first question, you might think it obviously is red again. But let's look at the mechanical energies. The balls start up here with equal potential energy. So they're starting at the same height relative to the Earth. And so they start with equal potential energy. And they both start with zero kinetic energy because they start from rest. They both travel the same distance down to what I'll call here a YF equal to 0. And therefore they must have equal kinetic energy because all of that potential energy has now been converted into kinetic energy. And they have equal mass, and therefore they must have equal velocity or speed when they come out, when they both reach the bottom here. What that does mean is that we saw here it had a greater, the ball on the red track had a greater acceleration, then an equal acceleration, and then a negative acceleration, and it slowed down. So it means when it reached this point here, it had an equal velocity or speed as the yellow ball, but it had a head start, it had a kick start, and so it spent a lot of its time at a higher velocity, and it means it's ahead of the yellow ball. So the yellow ball is still coming along, the red ball reaches here, and even though it's now at the same speed or velocity, it's ahead of the yellow ball. But collectively they then continue from that same velocity and accelerate downwards again now at the same rate and reach a new final velocity at the bottom, but where they'll both have the same final velocity. I hope you had fun thinking about the puzzler. Cheerio!